Okay, and we're back with exhaustiveness checking for our pattern matching. So I've made some progress since last time. There's a couple of changes. But jump to the code we had last time. Really everything centers around these two functions. There's generate, and I believe this was called something like trial expressions for type. Now it's called constructors because we have this notion of a pattern constructor that's different than patterns and different than expressions used explicitly for this work. It just wasn't that much work to make, and it's just better to not be sort of abusing or misusing a type. So we have this, which represents all of the ways you can construct a value really in this language, at least syntactically. Gets really interesting down here, right? Once we're past looks like I already had integer and character. Now I've added them back. So we've got a little bit to do here. So we actually have a bug. What I've decided is for character, string, and integer that I don't want to worry about matching on them at a more detailed level than just binding them. So I have this tri-state enum, and the third variant has a struct inside it. And we're actually getting an error that this pattern is useless because we don't generate any pattern constructors for this struct because its only field has no constructors because we're not generating any constructors for string because there's nothing that would eliminate a specific string. So if we were matching on the string, there's nothing. This doesn't eliminate this case. In fact, we're going to allow that actually, but the idea is that like if it's a different string, you still need to handle it exhaustively. So you eventually have to just do a binding, which you would do like this. Anyway, run into a bit of a bug because I'm not generating any pattern at all, like I said, for this case. So we get here and we're like, hey, there's no cases to dismiss, like not even this one, because the whole point is it's just recursive. So we needed to generate at least one possible pattern here for unknown. Where inside, I think we just say string, and we just don't really say anything about the pattern. And the only thing that will match it is a binding or a wildcard. So that's the plan. So I've added these new types, these three, to my pattern constructor, and I need to handle them in a few different places. So I'm just going to do that real quick. This is in our display or dump function. So char string int right here. There's really nothing to do here. I might try this. So this will be double quotes and then for int. We'll do that. I don't love this, but you know, let's just move on. And yeah, so this is where we were generating nothing for these types, and we need to generate something so that we force the user to do a binding or wildcard expression. So that's that. And now we need to talk about what we consider a match. So pattern matches. The main thing here is that the wildcard and the variable cases are going to match those constructors. And that's really all we want to do because even though in the language we support supplying a string literal and we will do the equality check, we don't want that to count as eliminating that case. Because I just think I want to be I think this is good enough for now for pattern matching. So that's pretty much why. Yeah. Hope that is enough background info and intro. We get in here. I think that might even be enough to get what I want to work. So if we go ahead and run this guy. Sorry, still warming up. So we failed to compile. No. Okay. It completely succeeds. Gotcha, gotcha. All right. So here's our trial constructors. Okay. And there's our dump. Okay, I think I'm happy with this. So maybe let's do some testing. Unknown. That's just going to be the struct. So I should be able to do s.reason. And now let's match tri-state. So we should get that. And then, and that's not actually it. It's a struct with reason. Because is fine. Right, expected tri-state, but got .yes. It takes an optional tri-state. This seems wrong. This also seems wrong. But if let's just help the compiler out a little. Okay, yeah, so I think we've got something going wrong with our type inference. So we'll rename this to match tri-state opt. And maybe we'll fix the bug later. And for now, what we could try is matching a non-optional version. So I had kind of wrapped everything in option because I was worried about that recursion. Let's try this. So we'll do it before. Okay, that works fine. So I think that our type hinting is not going through option. So what I mean by that is a lot of how the enums work in this language have to do with expecting a certain type inside that spot so that we know, so that we can say just .yes and we know which enum that .yes is meant to come from. And I have a feeling that inside a sum constructor, we're not doing that. So the place to, I'm just going to go to my typer, which is a big old file, and I'm going to search for the string sum. And I think I found the spot immediately. So this is why having large files might not be such a big problem. The thing you should think about with your modules and your code in general is not maybe how much text is in one file, but think about if you were to imagine the actual code in that file and the actual functions when they call each other. Think about how interdependent they are, or how not even how many paths through, because there can be lots of paths through and the code be very simple, but how entangled they are, interdependent, right? In this case, it only takes a couple of jumps to get to a spot in the compiler where it's very clear from the function name what we're doing. So here, we're in resolve parsed function call, which is the only function that takes a parsed function call, so a thing from the syntax tree, and decides which function is actually being called. So this is all function resolution. And sum happens to be a special function because option is a special built-in type. So here we're going to evaluate the inner expression to the sum, and then we're going to wrap it in a sum. But what you may notice is, I think the LSP died, but that's okay. We can just be without LSP for this one. So we go to fun eval expert inner, and we see that third argument is called expected type. That's our type hint. That's really important for what we're doing here. So this needs to be not that. Unfortunately, I lost my spot. Here we go. Yeah, so we have an expected type, I think. It's not even passed. So because this is such a special case, and this is kind of a shortcut edge case in resolve parse function call, because that doesn't actually result in a function call. This just results in a sum expression. It's just a function call syntactically. And I kind of do that on purpose for a lot of things where I parse it as a function call because it's just a very powerful and general construct in the AST because it can take as many arguments as you want. It can take type arguments. So for a lot of built-ins or things that don't actually become function calls, I parse them to function calls syntactically in the parser so that we can then kind of unwind and handle them here. Return is an example of that as well. So here we go. This needs to take expected type. So we're going to go to where this is called. And it looks like it's called in one place. We're going to pass in our expected type that we already had. Coming back up, go back down to our sum. One thing that I think I could improve my Vim usage that I want to learn to do is I make really heavy use of the jump list forward and back. I just go back till I find something where I know where I am and then jump around, and same with forward. But what I could have done here is I could have made this a mark. So I just typed MA. So now my mark is here, and then I could have done, hey, let's jump to this function. On eval expert inner, okay, and this takes this, and then I could just do tick A and come right back where I was. I think that's going to be a pretty good way to work, especially in multiple files. It does work if you use capital letters for your mark register name, and I think that that's a way that I could really improve my my navigation and flow if I would remember to make a mark before I navigate away from somewhere I know I'm coming back to. I don't think that's too much like cognitive overhead to learn to do. There's always this balance between trying to improve your flow so much that you end up thinking about counting line numbers or improving your flow rather than just staying focused on your problem. So here we are. So we now have an expected type, but let's think really carefully here. So if we were expecting, here we are expecting an option of tri-state. So what should we expect in here? A tri-state. It's really obvious looking at this code. We shouldn't also expect an option of tri-state here, because then we'd have one too many options, right? So we need to pull the option off and expect the inner thing inside. So so we're going to say let expected type inner, and that's going to be we're just going to match unexpected type, and if it's none, then we're going to do none. So I know I could map, but the problem with map in Rust is pretty soon you want to use question mark or you want to do something else, and It just feels bad to be inside a closure, and you end up switching the code to use a for and a match instead of like maps and that functional style. And that's just the way it is. I feel like when I do write something in that functional style, it's only one day, maybe two, till I'm back there changing it a little bit to be less functional and play nicer with the rest of the language. But that's also a little easier. So this is the okay. So we need to get the type. I've actually done this in another spot. So I'm gonna. So here's a place where I match unexpected type. Okay, exactly here. So we've done this for array. What we do is we match and then self types get. Okay. So this is the code we're going to write if we don't find that we've already done it a better way. And for dereference, match some. Okay, yeah. And then we did it for it's done for reference, and I think it's also done for, yeah, that's dereference, and this is reference. Okay, so expected timeout. Yeah, this is a little bit better. So we're gonna write it this way, and then we're gonna go back to our mark. Wow. Okay, I think that's achievable. I'm gonna do expected inner type because that's a better name. I've realized by now. So if we're expecting some unrelated type, we're not gonna like fail or throw an error or anything. It's not our job to do type checking. The type checker will handle this as soon as we return in the way that's more appropriate for what's happening. This is just about the hinting and getting the correct hint, if there is one, down to the evaluation of the child expression. Did we fix our bug? I don't think we did, because our Rust did not. Oh, I forgot I'm programming without the LSP. So okay. I think this looks okay. Okay, no, we are matching on this. Which means that shouldn't be there. Okay. Expected tri-state. I wonder if we have a named enum, if we should include it in the name here. So this is like check types, which should be working. So if we expect an enum, but we get an enum variant, this we didn't get that though, but got dot yes. Hmm. So we're going to go to display type. Yep. And for an enum variant, we're going to write the name of the enum out. So does an enum variant even have def-info? And then it would not be that, but it would be a dot. It does not, but its enum does. So we'll go to whoa. Ah, no. Types. Pub enum type. Typed enum variant. Takes some getting used to working without the LSP. I'm not sure I love it. Okay, so we just have to use enum type ID. What do we have here? Oh, this compiles. So I think what we have there is a tag. So we still have the wrong type. Where's tag? For now, we'll change it from 1 dot to 4. Yes. So what I'll do here for tags is render them this way. That might break some CodeGen stuff for now, but getting rid of these anyway later. So we're going to simplify how the enum variants are named and remove this idea of a tag. I was trying to do a Lisp symbol thing, but it's not really needed in this language. Okay. So we need to lift that tag up into yeah, this is a totally unrelated bug to pattern matching, but I guess kind of worth fixing right now. I don't know. That's what I'm doing. So let's try this. Yeah, so that works. So somehow we're not passing the correct because what should happen is Oh gosh. Right. Okay. We're passing tri-state in. So that's the right thing. So we fixed it here. Our problem is now with tag literal. So we're gonna get okay, and we're just gonna return the tag regardless of expected type, and then coerce is gonna so we're calling eval expert inner. So here, I'm calling my inner eval expert. I think I need to call the full-blown one because the one I'm calling actually skips exactly the step I want, which is this coercion from when we expect a certain type but we get a different type. If they're fully compatible, then we coerce. So that's how I do automatic dereferencing, automatic sumboxing, and it's how I allow the tags to get treated as the enum that they're actually expected to be, which will probably go away in a redesign. But anyway, this needs to just call eval expert, which let me just restart the LSP here, and we'll see if yep, that's correct. And it's all fixed. So we fixed 2 bugs. Kind of manifested as one issue in the same issue after the first was fixed, but that is a reason to have less edge cases like this. This might just go away once if I implemented that as an actual function in the language and get optional to be more userland defined, which is kind of where I'm trying to go. Yeah, just as some background where I'm trying to go with this, just for my own, so just kind of for my own exploration, but I would like to express 2 types that I built in from the beginning. So I built in the array, the dynamic array, and I built in option. And I did that because I had no idea how to implement generics and because there were tons of other things I just couldn't do, but including like deal with pointers and stuff like behind the dynamic array. But now I actually have, I think, everything I need to do this. So we have, we have integers of different sizes. We have this notion of pointers that can be converted to references, and they're opaque. So, any of this, your program becomes unsafe. But this is how you would implement, like internally, the dynamic array. And then for optional, we can actually do this. We can do type optional t, and that's going to be, just a struct with. We get to name it. So this is, I've been calling it the discriminant, but this could be has value, and it is a bool. I mean, this is exactly how it's represented in the codegen. And then we just do special thing in the parser to understand the question mark, right? That is optional t. And who knows, maybe we even make that userland at some point. But if we did that, then all we have to do is I think at the yeah we could do a function at the very outer level here in prelude or in built-in. Exactly. Something like this. And then, yeah, no special cases where we could possibly have a bug where we're not calling our code the way we call it everywhere else. Like this is a case we handle. Calling the correct function is a case that's obviously handled elsewhere in the compiler. So that's an interesting kind of aside on why I'd like to also just make the language a bit more, like correct or sound, like remove special things. As I kind of did this with these built-ins as well. Like I got tired of everything I had to do with them differently because they didn't have a location in the source code, and I couldn't attach definition info. I had to handle in the parsing stage, like simulate that they're pre-declared and all this stuff. And it's like it's actually easier and simpler to just to implement this little special right-hand side. So there's still special cases, but there's special cases in way less places because they're actually defined in the source. So similar with option, I would still build it in. I would still make it special, but it would also be defined as a userland struct. Anyway, let's get back to pattern matching. Here, 32 minutes in. What patterns should we be able to match? I guess we should call matchbooo. Read my mind. So we should see true, false, and then we should see false, false. False, false, false. That's really nice. Okay. Instead of tri-state, let's just do something fun. So failed with Baz. T, false. No, false. So instead of unknown, whoops. We're gonna make this failure. Failed with Baz. If so, this is just going to be assert funny, I had the LSP off, but I left Copilot on, but only in my language that it doesn't know. It's doing a pretty good job. Oh, I did this. No type named false is in scope. Yeah, I'd say so. I think that's okay. Function not found, match tri-state. That's true. That's also true. Oh, we got some good errors there. If you missed it, that was no variant unknown exists in enum tri-state. Uh, so how do I turn this into a test? It's good that it compiles. I want one that fails to compile. One issue I'm running into is if I make this into a failure test, then I have to remove all the success code from it and then just have this separate test for the compiler error. I need a way of having one file that yields like 5 compiler errors and asserting on all of the errors. Maybe by doing a comment at the line that errored. That would be pretty sick. I guess for now, the fact that this compiles is a big deal. And there are a couple of assertions. For matchbooo, let's, well, I don't even know how to turn this into assert. All right, so are you both true? What's fun is I don't have to name these. Assert not both true. Assert both true. That was a total overkill. Okay, and we're still passing. I'm pretty content with that. So I'm going to move. Also, I have this enum eggs test that's been laying around for a long time. Exhaustiveness and uselessness. Okay. So we need, I think we're just going to delete this. And let's make 2 failure cases. So, do I have any tests named match? I don't think so. We'll just move this in called match. And we'll do match useless. Okay. Hmm. String was a bad choice, I guess. Let's do this. It doesn't really matter what I produce. Let's just produce X every time. X +1, X +2, Y. Sure. I just want a somewhat interesting match that I can also add a useless pattern to. I get in so much trouble when I let Copilot write in this language. Okay. Okay, it worked. Okay, our new test passed. I knew a couple were failing. Let's just look into them. No, not the for yield string. I know that one's broken. Enum payload though. Useless pattern. Oh, interesting. Yeah, so we need to put it in partial mode. I didn't realize we were calling into this. So we do pattern matching with the is keyword, and of course it doesn't need to be exhaustive. So let's fix that. So exhaustive. Where are you called from? Eval matcharms. Yeah, so eval matcharms, partial. Yeah, it's a partial match. Let's do that. Do we put this all? Yeah, okay. If not partial. Yeah, I'm just gonna put it all inside. If it grows, we will move it to its own function. Now we just have a couple of places to fix. This is in eval match expert, so partial is false. Nope. Partial is partial. Looks like we call into this from the special case as well. Partial is false. Here from eval if expert. Sorry, you need an eagle eye. Eval if expert. Partial is true. And those are the only two places that we call. Let's run the test again, see how many of those that knocks out. One. What's wrong with struct composition? Ah. What? Oh, it's not inside an if. Oh, interesting. Right, there's three cases. Uh, is this an is expert? The condition is an is expert. We desugar to a match. And then we call in with partial true. Hmm. Eval matcharms. Partial. Okay. Eval match expert. Partial is true in the if expert case. Ah. What about an actual is expert? Oh, we call eval expert. That is tricky. We could put the partial nature of it on the AST. Struct composition's good to go now. That might be a number of the failures. Oh, Raylim FFI false. That's not what we meant. Ooh, 4-yield string is the only one. So what happened was I broke this. I broke the codegen of this when I was doing some refactoring. So we'll fix that later. But that's back to one failing, which is where we were when I started on exhaustive pattern matching. Let's just go back to our match useless and just sanity check real quick. Let's get rid of a case. Run file. It would fail on pattern x sum false. Unhandled pattern x int y sum false. It's just too good. Let's do that. Let's do match missing. match missing, match unhandled, and match useless. This will be unhandled. This will stay useless. I'm gonna have to fix it. All right, unhandled pattern. Boom, and then back to useless. I'm gonna handle some false twice. Okay, I think I matched the message correctly. Only one way to find out. I'm okay with that. Yeah, I think that's fine. There we go. Quite a bit of a diff. I did some refactoring of the code gen in this same commit as well, which you should never do in a serious project. But yeah, the fun thing about this is I just kind of do what I want. Can be a little bit irresponsible. I don't think we need is enumerable literal. Maybe we clean up some warnings actually. Let's get the LSP back on real quick here and see if we can again, look at a couple warnings. Oh, can I turn them on? Sure. Oh, they're gone. Oh, it crashed already. Okay, well, that's fine. Let's try running a file. Oh, that's not what I wanted to do. The AI was kind of helpful with this feature, I'll just say. If you were looking at my assistant history there, it was kind of useful. Yeah, I'm not seeing warnings. All right. I would think it would complain that is enumerable literal would be oh, maybe it's not. Yeah, we did end up using that because otherwise these, yeah, so this lets me still use literal patterns and I won't report them useless. We need to actually test that case. Let's just go to this one. Oh yeah, so it is working. So basically I can do exactly X and that's fine. And this should be printing X actually. Let me make sure it has been all along. Right, so we matched exactly X, but it's still saying, hey, look, you didn't match on char generally, so this is not gonna fly. So I gotta put in a case there, and then now, yeah, it has been printing X. So that actually is a function that we do need, is enumerable literal. I'll just scroll through here, maybe for the sake of the video. Anyone could I guess pause and look at what was written. So there's my entire pattern matching implementation, replacing my placeholder. My placeholder was actually longer. So that's really neat. This is actually where I broke I'm not gonna stage this because this is the the for yield where I broke something in this synthesized code. So we're going to go back and just use get magic of get to fix that mistake. Right, and I guess it's not entirely fair because we hid the implementation down here, but this function, and then the code we saw above is the entirety of pattern matching, of exhaustive pattern matching. We gotta do a nice display for our pattern constructor enum. Went ahead and did display for pattern. And that was it. Well, thanks for watching. I think that'll do it for the exhaustive pattern match videos. Done it in 2 parts. Yeah, it was quite a lot of fun and really a lot easier than I thought it would be. I am considering a couple of features added to pattern matching, which I would probably record if I did. The main one being multiple patterns, which you can just desugar to the pattern again with the same right-hand side. But I don't know. The other one is the Rust's range-based. So like, you can do for characters and anything that's a range, it actually does exhaustive range matching. And I actually read the PR that the guy wrote who implemented that feature like 5 years ago, and it's really, really cool. And it's the only language that does it. So maybe one on that, but it's just not that important to me. And with all the edge cases he laid out, it's actually really, really difficult. So probably not. Anyway, that's enough. That's enough rambling on at the end. As always, if you did watch all the way to the end here, I'm impressed and amazed, especially if you were awake most of the time. Yeah, I hope you learned something. Yeah, thanks for joining me. See you next time.